Okay, so we're going to do question 10.20. So in this question, it's just asking you to find the marginal products of capital and labor for each of the production functions in 1018. So over here, I also got the exercise 1018 over here with all of these production functions. So what we have to do is just to find the marginal products of capital and labor for these, and then find a marginal rate of technical substitution apart from part A. Okay. All right. So for marginal products of labor and capital, we start with part A first, where this is a perfect complement production function x equal to the minimum between CK and D L minus L0. Okay, so in order to find the marginal products of capital and labor for this production function, we will have to divide into a few cases, whether CK is smaller than DL minus L0, bigger or equal, okay? All right, so I got, now if CK is smaller or equal to DL minus L0, okay? Then I know that the production function is going to be equal to the minimum between these two. And because CK is smaller, so therefore the minimum is going to be equal to CK. So now it's very straightforward. The production function equal to CK. So therefore the change, so the marginal product of capital, which is the change in the production function with respect to K, is now going to be equal to C. Okay, so if you differentiate this with respect to K, you are going to get C. And the marginal product of labor is where you differentiate the production function with respect to L. In this case, as you can see, there isn't any L in the production function. So if you differentiate with respect to L, you get 0. Okay, so CK basically is just being treated as a constant when you differentiate with respect to L. And so therefore, if you differentiate a constant, then you get 0. All right, so that is the first case. Now the second case is where if CK is bigger than DL minus L0. Now if this is the case, then the production function is now going to become so it's still the minimum between these two, and since CK is now bigger, therefore the production function is equal to DL minus L0. Okay, so again, very easy to find marginal product of capital and labor, where marginal product of capital is just the change in the production function given the change in capital. Again, as you can see, there isn't any K over here, so the whole thing is just being treated as a constant. So when you differentiate with respect to K, that will just give you 0. Okay, and to find the marginal product of labor, you just differentiate with respect to labor, and that is going to give you D. Okay. Remember, L0 is just a constant, so that will disappear when you differentiate. All right, so that is the marginal product of labors and capitals for the first production function. Okay, so we go into the next production function, where x equal to sk plus TL. So x equal to sk plus TL. Now this is the perfect substitute production function. Okay, so again, this is very straightforward. If you differentiate x with respect to k, as you can see, you straight away get s. All right, the TL will disappear because it's just a constant when you are differentiating with respect to k. And very similar, marginal product of labor is the differential of x with respect to L, and that will give you T. And so the marginal rate of technical substitution is just going to be the negative of the marginal product of capital divided by the marginal product of labor. Okay, now if anyone is wondering whether it's okay to put MPL on MPK, again, it is totally fine. Okay, it's just like marginal rate of substitution. You either put one variable on top of the other or the other way around. It's totally fine. Okay, just again, just have to remember when you draw a graph, if you put k on top in the marginal rate of technical substitution, then k has to be on the horizontal, just exactly the same way as when we draw the indifferent curve for the marginal utility. Okay, so when you draw the isequent for this production function, if you are putting mpk on top when you find the marginal rate of technical substitution, then k has to be on the horizontal axis when you draw a diagram. That's all. Okay, so in this case, marginal product of capital is S and labor is T. Okay, so the next production function is x equal to 50 log of k plus L. Okay, so again, very straightforward. Marginal product of capital is just change in x, even a change in k. So over here, basically you would need to use the chain rule where you're treating the whole thing inside log as a function. Okay. So if I'm treating this as a function f, okay, then the change in x given a change in k is going to be, so this is just, so this is like x equal to 50 log of f. Okay, so if you differentiate x with respect to k, you basically differentiate x with respect to f first, and then you multiply by the differential of f with respect to k. Okay, so this is the chain rule. If I differentiate x with respect to f, I got x is a function equal to 50 log of f. So if I differentiate with respect to f, I get 50 1 on f. Okay, and multiply by the differential of f with respect to k. Now given that f equal to k plus L, if you differentiate f with respect to k, you get 1. Okay, and now we just have to substitute the value of f, which is k plus L. And so that is our marginal product of capital. All right, so very similar marginal product of labor is just going to be, again, just the change in x given the change in f times differential of f with respect to L. So again, differential of x with respect to f is 51 on f, and multiply by the chain of f with respect to L, which is 1. Okay, so again, that is just 50 divided by f, and f is k plus L. All right, so therefore, marginal rate of technical substitution is negative k marginal product of L, and that just gives you negative 1. Okay, and the next production function is x equal to k power a L power 1 minus a. Okay, so therefore marginal product of, again, capital, it's just the change in x given the change in capital. And so now it's pretty straightforward. We have been doing this for so many times. We are treating L as a constant. So L1 minus a will remain there as a constant. And when you differentiate k to the power alpha, you get alpha k to the a minus 1. So this is a alpha, a. Okay, so k to the power a minus 1. And marginal product of labor is just the change in x given the change in labor, and that is, so k to the power a is just a constant, remain there. 1 minus a is, so if you differentiate L to the power 1 minus a, you get 1 minus a L, 1 minus a minus 1. Okay, so that will give you k a 1 minus a L negative a. So therefore, the marginal rate of technical substitution is negative of marginal product of capital divided by marginal product of labor. So I got a L1 minus A, K, A minus 1, everything divided by 1 minus A, K, A, L negative A. So what I want to do is to try to get rid of all the negative signs on the power. So if I move L negative A to the numerator, so I get L1 minus A times L A. And if I move K to the denominator, okay, I got 1 minus A, K times A power A times K power 1 minus A. Okay. So if I move K power A minus 1 to the denominator, it will change the sign of the power. And so it's going from A minus 1 becoming 1 minus A. So that is just going to give me A on 1 minus A. Now L power 1 minus A times L power A will give me L. Very similar denominator. On the denominator, I'll get K. All right, so that is the marginal rate of technical substitution for this case.